Hello everybody. Today I'd like to do something from trigonometry. I'd like to derive some values from the unit circle. So let's do a really quick drawing here of the unit circle. You can use this circle tool to make it a little bit easier. Well, let's see. I want to make this as close to a unit circle as I can. So something like that, sure. All right, so there we go. We got our unit circle. And there's some kind of somewhat obvious values that are on the unit circle if we think about what a unit circle means. A unit circle means that it's a circle with a unit radius. Circle. So a unit circle has radius of 1. So we can label some of these more obvious points on the unit circle as follows. This is the point 1, 0. Oh, and just bear in mind this is for a unit circle centered at 0, 0. All right, let's get these values. This is 0, 1. This is negative 1, 0. Just because this is my x. And this is 0, negative 1. All right, so we got some of the nicer values, but let's look at the one that's smack right here in the middle. So this is a 45-degree angle, and we want to know how tall a triangle would be here and how long its base is as well. Uh, another word for these values, this is the cosine of 45 degrees. And right here, this vertical right here would be the sine of 45 degrees. This comes from SOHCAHTOA. Review that if need be. But anyway, here we are. So we know this point has the coordinates. I'll write them up here. This is cosine 45 degrees. And then this is the y coordinate is sine of 45 degrees. All right. Now the question is, what do these actually equal? Because we've just given them names. We haven't really done anything mathematical yet with these. But here's how we'll approach it. So let's just take a sketch of that triangle that we have over there, except on this side. We know that it's a right triangle based on how this is just straight down. And then we know this is 45 degrees. And because the angle sum of a triangle, or rather the sum of the interior angles of a triangle is 180 degrees, that must mean that this angle right here is also 45 degrees. Another way to see it is just that I cut this halfway, halfway along this arc. So yeah, each of these angles is 45 degrees. Now, we want to find out what this is right here and what this is. So what we're going to do is we're just going to give this a name. These have to be the same because they're both across from 45-degree angles. Thus, we should just use this to figure this out. And then there's one more key piece of information we need, and that's the Pythagorean theorem. The Pythagorean theorem. All right, and what the Pythagorean theorem tells you is that if you have a right triangle, the two shorter sides, if you take those two shorter sides and square them, so here it would be x squared. If you square each of them and add them together, then you'll get the hypotenuse, the longest side, squared, which would just be 1 squared in this case. After a little bit of basic algebraic simplification, we get that this is 2x squared is 1. Dividing by 2, we get that x squared is 1/2. Taking the square root of both sides, here and here, leaves us with x equals well, really we should have plus or minus the square root of 1 over 2. But because we are working in the first quadrant here, we can just disregard the minus. We'll just work with just the plus here. And notice if you take the square root of 1, you just get 1. You take the square root of 2. There's no really better way to write this except for maybe rationalizing the denominator. To rationalize the denominator, we just multiply by root 2 over 2. This will, you'll see on the top we'll just get root 2. And of course the square root of 2 times the square root of 2 is 2. So if you've ever seen this mysterious looking value on the unit circle, this is actually where it comes from. We can derive it directly with the Pythagorean theorem, and that's practically all we used.